Hello and welcome. So given a circle, we have some tangent lines to it. We want to find the various lengths, missing information, so on and so forth. We can see all the information, right? All the information here is actually labeled in the diagram, which is nice. Okay, now first off, tangent lines, meaning that we have a line that intersects with our circle at one point. So we have two tangent lines, right? E and G are that point of tangency. Now the reason why we need to care what tangent lines are is because we have two properties. The first off, the property that says that anything from the center to the outside, right, the radius, is going to intersect a tangent line at a right angle. The second most important thing says that when you have tangent lines, the intersection of those tangents to the circle, the point of tangency, is the same length, meaning that those are congruent. Well, first off, it wants to solve for x, so let's look at our sides first. Congruent means essentially equivalency in mathematics, meaning equals. That means that 13x plus 10 is the same as, it's equal to negative 9x plus 16. So then we just solve for x. Going to add 9 to the other side. I'm going to subtract 10 at the same step as well. Save a little time there. So we have 22x equals 6. Divide by 22 to get x alone. And we get x equals 6/22. Be careful, it says a simplified exact answer, so it wants a fraction, but a simplified fraction. 2 is the common number here. 2 goes into 6 3 times and goes into 22 11 times. So 3/11 will be our final answer here. Alright, now next it wants us to find the actual length of the segment G to J. Now it's going to be that little highlighted segment there at the bottom, right? G to J. So all we can do to find that, we have x, plug in x. So we have negative 9 times 3/11 plus 16. Now, if you're not confident with your fraction arithmetic, that's okay. You can whip out a calculator, right, at this point. So we have negative 27/11 plus 16, right? So when we do that, it'll be essentially 16 minus your 27/11. And when we do this, we end up getting the fraction of 149 over 11. And that's as simplified as it gets. It's not going down anymore, so 149/11. Now what's cool is that we know that those segments are congruent, meaning that this side also equals 149 over 11. Pretty nifty, right? Now for the next section, we're going to be giving approximate answers, meaning decimals. It says to round to the third decimal place. So we're looking for the segment A to J. Well, A to J is this little middle segment right there. And how can we find that? Well, using that first property, we know this is a right angle, which means that this is a right triangle. And if you have a right triangle, we know that the Pythagorean theorem is a thing, meaning that if you have a leg squared plus the leg squared equals the hypotenuse squared with our Pythagorean theorem. And we know that our segment here, A to J, is the hypotenuse because it's across from the right angle. So we'd say, all right, well, what do we want to call the hypotenuse? I don't know. W, sure. Okay, so we have W squared, whatever that length is, squared. Equals, and then what we have for our two legs, we know that one leg is 149 over 11, right? We know the other leg is 11, right? And there you have it. There is your setup. So I'd go straight to your calculator, right, and actually have it put in here. It's right this second box here. We have 304.4793388, so on and so forth. Okay, and that's essentially the same thing as that lovely chunk fraction there. But do we need to know the fraction? No, we don't, because think about it, we're going to be rounding anyways, so we're going to get some number 304 point stuff, right, equals W squared. Well, what's your next step to solve for W? Take a square root, right? So then you're going to be taking a square root of that number, which you can see right here in this step. We get 17.449. Now notice I'm using the entire decimal as far as my calculator will give me for that square root. Do not round off your answer too early. Okay, this is going to be a little finicky on rounding. Make sure you don't round to the end. So 17.449 is going to be our answer for this one. Okay. Alrighty, so now we're on the last one, which is the measure of angle EAJ. Well, E to A to J is right there, which means that the angle we're looking for is going to be, right, E to A to J, that little segment in between. Well, that's helpful because we know a couple of things. First off, it's a right triangle. So if we're looking for, this angle right there in the corner, right, then we'd say, all right, well, let's use sides that we know for sure, not approximate sides. So we know this one is exact. We know this one is exact, right? It's 149/11. And then you can use your SOHCAHTOA, right triangle trigonometry for this one. Whenever you need an angle with a right triangle, think SOHCAHTOA, right? So SOHCAHTOA is going to be what we use. Now, when we're looking at this one, we'd say, all right, well, here's our angle. This is the adjacent side. It's right next to our theta, and this is our opposite side. It's across the triangle from theta, which means that we're looking at an opposite and an adjacent side. And the only trig function that uses opposite and adjacent is tangent. So then we'd set this up and we say, all right, so tangent of theta equals our opposite side, 149/11, over our adjacent side, 11. I'm going to make this a fraction. It's 11/1. Divide by a fraction, multiply by its reciprocal. So we have 149/11 times 1/11, which is 149/121. Okay, so that means our tangent of theta equals 149/121. We'd say, okay, well, now remember the goal. The goal is to solve for theta. It's attached to a tangent right now, and we can only undo tangent with its inverse operation, inverse tangent, which means that we have inverse tangent to this thing, inverse tangent to that thing, right? These will cancel out. They leave you with your theta, and we get theta equals this thing, the inverse tangent of 149/121. Now remember, this one says don't worry about the degree symbol. Keyword being degrees, you need your calculator in degree mode. So we're going to turn back here. All right, notice I already have our in. We know this, see this little slider moving, right? The DEG means we're in degree mode. You can see it changing between modes there. You need it in degrees. And we get 50.921. 6 will round up. So 50.921 degrees. And that's it. That is your final answer for this one. Thanks for watching.